Today, we are testing a 100 kg/H lithium battery recycling line before shipment to our customer in Kenya. This line is designed for the physical recycling of waste 18,650 lithium-ion batteries. Unlike thermal recycling methods, this system uses mechanical shredding and physical separation to recover valuable materials from spent batteries. The first key step is the single-shaft shredding system. The shredder breaks down the waste batteries and helps release the different materials inside the battery. This step is important because proper size reduction creates better conditions for the following separation processes. After shredding, the material moves to the air separation system. Here, the airflow helps separate materials according to their different physical properties and densities. Lightweight materials, such as plastic and separator materials, can be separated from heavier materials and collected for further processing or recycling. This physical separation step helps reduce impurities and improves the efficiency of the following processes. Next, the material enters the vibrating screening system. The vibrating screen separates materials according to particle size. Fine particles can be separated from larger pieces, making it easier to collect the valuable black mass and further separate the metal components. Black mass is one of the most important products recovered from lithium batteries. It contains valuable battery materials from the electrodes and can be further processed for resource recovery. After screening and separation, the black mass is collected through the dedicated black mass collection system. At the same time, the remaining metal-containing materials continue through the recycling process. The system then focuses on the separation of copper and aluminum. Copper and aluminum are important recyclable metals found inside lithium-ion batteries. Through physical separation technology, these valuable metals can be recovered and collected separately. At the end of the process, the recycled materials can include black mass, copper, aluminum, plastic, and separator materials. Each recovered material has its own recycling value and can be used as a resource for further processing. This is the main advantage of a physical lithium battery recycling process. Instead of relying on thermal treatment, the system focuses on mechanical size reduction and physical separation. The process is designed to recover valuable materials while keeping the recycling system efficient and practical. For small and medium-scale recycling operations, a 100 kg/H system can provide a flexible solution for processing waste lithium batteries. Of course, the actual recycling process and final recovery results can vary depending on the battery type, material composition, moisture content, and operating conditions. That is why testing before shipment is so important. For this project, the complete 100 kg/H lithium battery recycling line is being tested at our factory before being delivered to our customer in Kenya. During the test, we checked the feeding system, shredding performance, material conveying, separation efficiency, screening operation, black mass collection, and copper and aluminum recovery. We also pay attention to the stability and coordination of each individual machine. A complete recycling line is not simply a combination of separate machines. Each section needs to work together smoothly to achieve stable material flow and effective separation. The pre-shipment test allows our technical team to identify and adjust any potential issues before the equipment leaves the factory. It also gives our customer greater confidence in the equipment and the complete recycling process. From waste 18,650 lithium batteries to black mass, copper, aluminum, and other recyclable materials, every stage of the process is designed around material recovery. If you are looking for a lithium battery recycling solution, for 18,650 batteries or other battery materials. The recycling process can be customized according to your material, capacity, and recovery requirements.